Okay. Now let's start with the next inorganic chapter, that is P block elements. This also, from theory point of view, we have already completed. Many of the things we have already discussed in the periodic table also. So many of the things are a quick revision. And questions किस point of view से पूछा जाता है, that is what we are going to stress upon in this session. So let's start with the group 13 elements. Before we start, a small introduction. P block elements are those elements in which the last electron, which is also called as the differentiating electron, will enter in the p orbital of the ultimate shell. So in the electronic configuration, if the last or the differentiating or the valence electron is in the p orbital, then it will be a p block element. Next, we know that a p subshell has a max capacity of p subshell has a max
6.
capacity of 6 electrons, because p subshell के अंदर होते हैं 3 orbitals and they are represented by px, py and pz, and each orbital have a capacity of 2 electrons, which gives a max capacity of p subshell as 6 electrons, and that's the reason we have 6 groups in the periodic table starting from 13 till 18. And P block में each of the group is named with respect to the first element of that group, meaning group 13 starts with boron, we call it as boron family, group 14 is the carbon family, group 15 is the nitrogen family, which because of the toxic nature is also named as
Nicogens.
licogens. ठीक है? So now starting with the group 13 elements, the boron family. Electronic configuration for the boron family is the general electronic configuration. Yes,
NS2NP1.
perfect. Because for the entire p block family, the configuration is ns2 np1 to 6, where the electron is progressively filling in the p orbital. So for the first p block element group, the electronic configuration would be ns2 np1. So based on this configuration, how many electrons does it have in the valence shell?
3.
Um, 3 electrons in the valence shell. Because of that, the max oxidation state shown by this group, the boron family, is
+3.
+3. So we say the maximum oxidation state for the p block is equal to the number of valence electrons, or it is equal to the sum of the s and the p electrons. The maximum oxidation state for the p block is equal to the sum of the s and the p orbital electrons. So if I move to the group number 17, which has a configuration of ns2np5, the max oxidation state for the halogens is found to be
+7.
+7. Fine. Now the other oxidation states for this particular group are what?
+1, +2.
+1 and +2 won't be that favorable. Generally, after +3, there will be +1 oxidation state, because इस एक इलेक्ट्रॉन को निकालना easy है because it is the unpaired electron, followed by the removal of this 2 electrons together would give an oxidation state of +3. जो intermediate +2 है, that won't be that stable or favorable. +3 क्यों stable होगा? Because after the loss of 3 electrons, it will acquire the inert gas configuration, which will be stable. और P1 इलेक्ट्रॉन निकलने के बाद भी S2 configuration मिल रहा है, जो कि काफी stable है. इसे +2 is not that stable. So generally, in the P block elements, the other oxidation state differs by differs by a unit of 2. May not be always the case, but in most of the cases, if you see, the difference in the other oxidation states will be by the units of 2. तो जैसे हम हेलोजेंस में बात करते हैं, apart from +7 as the max oxidation state, other oxidation states were क्या क्या थे?
+5, +3.
+1 and -1 also. So it's 1, 3, 5, 7, +1, +3, +5, +7 and also a negative oxidation state of -1. ठीक है? Now +1 तो हो गया positive oxidation state की बात. What is the negative oxidation state which this group can show? नेगेटिव ऑक्सीडेशन स्टेट क्या बता सकता है?
-5.
-5. Now you are thinking on the basis of filling of the p orbital, right?
Yes, sir.
So यहाँ पे अगर हम बात करें तो नेगेटिव ऑक्सीडेशन स्टेट्स में -5 पॉसिबल होगा, बट इट इज नॉट शोन बाय मेनी ऑफ द एलिमेंट्स. अगर हम थैलियम या फिर गैलियम की बात करें तो दे हैव अ टेंडेंसी टू शो अ -2 ऑक्सीडेशन स्टेट, because with -2 it can acquire a half filled configuration, because उतने इलेक्ट्रॉन एक्सेप्ट करने के लिए भी a lot of energy would be required. ठीक है, तो इसमें -2 एंड -5 के ऑक्सीडेशन स्टेट थियोरेटिकली पॉसिबल है, बट स्टेबिलिटी वाइज द -2 ऑक्सीडेशन स्टेट वुड बी मोर फेवरेबल. ठीक है, तो जनरली ये ग्रुप में प्लस या पॉजिटिव ऑक्सीडेशन स्टेट इज मोर फेवर्ड. अच्छा, बाय द वे, व्हाट आर द एलिमेंट्स इन दिस ग्रुप अपार्ट फ्रॉम बोरॉन? हाउ डू वी रिमेंबर दिस?
बार गंगाधर
गंगाधर
इंडियन
इंडियन
कलर।
कलर।
सो दैट्स अ वेरी फेमस ग्रुप जो हमने पीरियोडिक टेबल में बहुत डिटेल में किया है. इट्स बाल गंगाधर इंडियन तिलक, दैट इज बोरॉन, अल्यूमिनियम, गैलियम, इंडियम एंड थैलियम. ठीक है. Now, if I talk about the nature of boron, is it metallic, non-metallic, or metalloid?
Non-metallic.
Boron is non-metallic because of high electronegativity. What about others?
Metallic.
The others are metallic in nature. तो यहाँ पे सिर्फ बोरॉन जो है, because of high electronegativity, high ionization enthalpy, is found to be non-metallic. The others are found to be metallic. And we know that the metallic nature goes on increasing down the group because of the decrease in electronegativity. Next, coming to atomic radii, what is the general trend? Down the group, it will
Increase.
increase. But with the group 13, there is an exception, and it should be a well-known exception. किन दोनों एलिमेंट्स के बीच में है वो?
Aluminum and gallium.
And the reason is
Shielding effect.
of which electrons?
The electron in the d orbital.
Perfect. So we say that aluminium gallium में theoretically gallium should have been larger, but it is found that gallium is smaller than aluminium because of the poor shielding effect of the 3d10 electrons. And that's why when we write the order for atomic radii, boron is the smallest, followed by gallium, then comes aluminium, and then normal trend indium and thallium. This is what is the exception, and this is the order. Clear? Aluminium के केस में the configuration is neon with a 3s2 and 3p1, और गैलियम में जो configuration है that is argon 4s2 3d10 एंड 4p1। दोनों में वैलेंस कॉन्फ़िगरेशन तो सेम ही है, लेकिन गैलियम में जो 3d10 इलेक्ट्रॉन है, इट ऑब्स्ट्रक्ट्स द अट्रैक्शन बिटवीन द न्यूक्लियस एंड द वैलेंस इलेक्ट्रॉन। और ये जो डी का शील्डिंग पावर है, दैट इज पुअर। दैट इज व्हाई द वैलेंस इलेक्ट्रॉन गेट अट्रैक्टेड टू द स्ट्रॉन्ग न्यूक्लियर चार्ज, and that is the reason we say that the shielding power dominates the nuclear charge and the size decreases. Then comes ionization enthalpy. Even this as a property for specifically boron family is very important. Can you tell me the trend or the order?
Boron is highest.
Boron is highest, followed by
Then thallium.
perfect. Then
Then gallium.
perfect. Then
Then aluminium and then indium.
perfect. ये ऑर्डर बहुत डिटेल में हमने डिस्कस किया है पीरियोडिक टेबल में। हाईएस्ट आयोनाइजेशन एंथैल्पी तो बोरॉन का होगा, एंड डाउन द ग्रुप इट विल डिक्रीज। Between aluminium and gallium, since aluminium is larger, it will have a low ionization enthalpy as compared with gallium. So this is justified. अब थैलियम में आयोनाइजेशन एंथैल्पी बाकी सब एलिमेंट से एक्सेप्टिंग बोरॉन हाई क्यों हो जाता है? Because when we write the configuration of thallium, it is xenon followed by 6s2 6p1। अब उनके बीच में there is 4f 14 and 5d 10 electrons, and this two collectively, that is 24 electron, actually offers a very poor shielding effect. So again, इस poor shielding effect की वजह से there is a very high nuclear charge of thallium, and there are these valence electrons, that is 6s2 and 6p1. But due to the poor shielding effect, these electrons would be very strongly attracted to the high nuclear charge। इसलिए इन इलेक्ट्रॉन्स को निकाल पाना काफी डिफिकल्ट हो जाएगा, एंड अ वेरी हाई अमाउंट ऑफ एनर्जी वुड बी रिक्वायर्ड। That's why the thallium has a ionization enthalpy which is much greater than the other elements except boron। इसलिए ऑर्डर में बोरॉन सबसे हाईएस्ट है, फॉलोड बाय थैलियम, एंड देन गैलियम अल्यूमिनियम, एंड लास्ट में इंडियम आ जाता है। ठीक है। इलेक्ट्रोनेगेटिविटी, again there was an irregularity in electronegativity of p block, group 13। so theoretical trend would be down the group it decreases, but in boron family
Gallium is more than aluminium.
it's not only between gallium aluminum, it's boron highest with a value of 2, followed by aluminium with a value of 1.5, and then it increases after aluminium, that is aluminium ke baad gallium, indium and thallium are more electronegative with electronegativity value 1.6, 1.7 and 1.8। मतलब बोरॉन सबसे ज्यादा इलेक्ट्रोनेगेटिव है और अल्यूमिनियम इस ग्रुप में सबसे लीस्ट इलेक्ट्रोनेगेटिव है, एंड दैट इज व्हाई इट इज मोस्ट मेटेलिक ऑफ द एंटायर ग्रुप। फाइन। Each of this trend is very important: atomic radii, ionization enthalpy, and electronegativity. Next, coming to the physical properties. So we know that boron is non-metallic, and apart from its non-metallic nature, it is extremely hard and black colored solid। जो smaller elements होते हैं वो काफी hard होते हैं, and the hardness down the group decreases। So that is the reason in the S block elements also we have seen that the smaller elements had a higher melting and the boiling point because of its hardness and also a strong metallic bonding within the element। So boron भी उसी फॉर्मेट के बेसिस पे अगर देखें तो नॉन मेटेलिक है, इट्स एक्सट्रीमली हार्ड एंड ब्लैक कलर्ड सॉलिड. इट एग्जिस्ट इन मेनी allotropic forms. Two are important, that is crystalline boron and amorphous boron. Crystalline and amorphous. Now just remember that crystalline matlab the atoms in that element would be very um the atoms in that element would be perfectly arranged, and amorphous के केस में there will be an irregular arrangement. तो परफेक्ट अरेंजमेंट की वजह से उस पर्टिकुलर लेटाइस स्ट्रक्चर को अगर हम देखें तो इट विल बी वेरी स्ट्रांग. एंड बिकॉज ऑफ दैट बोरॉन का जो क्रिस्टलाइन फॉर्म है दैट इज वेरी वेरी हार्ड विथ अ हाई मेल्टिंग पॉइंट एंड इट इज ऑलमोस्ट इनर्ट और अनरिएक्टिव. बोरॉन के जितने भी रिएक्शंस होते हैं वो एमॉर्फस बोरॉन के होते हैं, ना कि क्रिस्टलाइन बोरॉन का. Remember, boron reactions happens for the amorphous boron only, that I'll discuss in chemical properties also. So due to the very strong crystalline nature, strong इसलिए क्योंकि there is a regular arrangement of the atoms in the boron element. So boron has unusually high melting point. And if you look at the values in the table, the melting point and the boiling point is enormously high. बाकी सबका इतना ज्यादा नहीं रहता है. The difference is huge. So boron is non-metallic, extremely hard and black colored solid. दो allotropic forms में exist करता है, crystalline और amorphous. क्रिस्टलाइन बहुत ही ज्यादा हार्ड होता है, ऑलमोस्ट अनरिएक्टिव होता है, और amorphous जो है वो इतना हार्ड नहीं रहता है, इट इज एक्चुअली रिएक्टिव. In fact, any reactions of the boron are associated only with amorphous boron by default. Then as we move down the group, the hardness decreases, so rest of the members are soft metals with a low melting point and high electric conductivity. सॉफ्ट मेटल्स है इसीलिए मेल्टिंग पॉइंट कम होगा और इलेक्ट्रिकल कंडक्टिविटी ज्यादा होगा, बिकॉज उस केस में जो बॉन्डिंग है दैट वुड बिकम वीकर, एंड दैट इज व्हाई द टेंडेंसी टू कंडक्ट इलेक्ट्रिसिटी वुड बी मच हायर. Then a very important point. It is worthwhile to note that gallium with unusually low melting point, just about 30 डिग्री सेल्सियस. 30 डिग्री सेल्सियस मतलब रूम टेम्परेचर पे भी वो मेल्ट हो सकता है. एंड द रीजन इज ड्यू टू द एग्जिस्टेंस ऑफ ओनली Ga2 मॉलिक्यूल्स. मतलब गैलियम के स्ट्रक्चर में सिर्फ Ga2 यानी डाई एटॉमिक गैलियम के मॉलिक्यूल्स होते हैं, एंड दैट इज द रीजन द गैलियम हैज अ वेरी वेरी लो मेल्टिंग पॉइंट, so low that it can melt even at the normal conditions. मतलब रूम टेम्परेचर पे भी मेल्ट हो जाएगा, and that is the reason it could exist in liquid state during summer. Its high boiling point makes it a useful material for measuring high temperature. तो गैलियम का जो मेल्टिंग पॉइंट है वो लो है, लेकिन द बॉइलिंग पॉइंट इज हाई. Boiling point is determined with respect to the intermolecular attractions. बॉइलिंग पॉइंट इंटरमोलिकुलर अट्रैक्शन से रिलेट होता है, और मेल्टिंग पॉइंट जो है इंटरनल जो लेटाइस स्ट्रक्चर है उसके ऊपर डिपेंड करता है. तो दिस इज वेरी इंपॉर्टेंट टू बी नोटेड ओवर हियर दैट gallium has a low melting point and a high boiling point, and that is why it is used in many of the thermometers as a replacement for toxic mercury. So अगर ऑर्डर ऑफ मेल्टिंग पॉइंट की बात करें तो बोरॉन का सबसे ज्यादा होगा, फिर अल्यूमिनियम, देन थैलियम, देन इंडियम, एंड लास्ट में गैलियम है. वेरी वेरी लो मेल्टिंग पॉइंट. और थैलियम इंडियम में भी आप देखोगे तो ऑर्डर में डिफरेंस है, बट बॉइलिंग पॉइंट में एज अ ट्रेंड इफ यू सी इट इज डाउन द ग्रुप गोइंग ऑन डिक्रीजिंग. So to summarize, in the second point, what you are supposed to remember, melting point of boron family have irregularities, and in that gallium has unusually low melting point क्योंकि उसके स्ट्रक्चर में सिर्फ Ga2 molecules exist करता है, and because of that the melting point order is boron, then aluminium, thallium, indium and लास्ट में गैलियम है. लास्ट में गैलियम है. उसके बाद डेंसिटी. Density of the elements increases down the group from boron to thallium because of the increase in the molar mass and decrease in atomic volume. So इसमें regular trend है, density डाउन द ग्रुप इंक्रीज होती है. जैसे एस ब्लॉक में भी लीथियम से सीजियम बढ़ता था, बेरिलियम से बेरियम बढ़ता था, यहाँ पे बोरॉन से थैलियम भी बढ़ेगा. तो जहां पर रेगुलर ट्रेंड्स हैं, यू नीड नॉट रिमेंबर दैट, यू जस्ट रिमेंबर द सिंपल ट्रेंड ऑफ द प्रॉपर्टी. बट जहां जहां अगर हम बोरॉन फैमिली की बात करें तो एटॉमिक रेडाई इरेगुलर ट्रेंड है, आयोनाइजेशन एंथैल्पी एक्सेप्शन है. देन वी हैड टॉक्ड अबाउट electronegativity, that was exception. Then melting point, exception. तो जहां जहां exception है, just make it a point and remember it. Internal reasons मैंने दिए हैं, but finally you are supposed to just remember this trend. Now coming to the chemical properties, the oxidation state and trends in chemical reactivity. As I've already discussed, the common oxidation states for this group would be +1 and +3. Now, the moment we have the variable oxidation state, we talk about the stability. And the stability of these oxidation states is determined by which effect? The stability of variable oxidation states is determined by which effect?
Inert pair.
Inert pair effect. And what's the simple conclusion of that?
If it's a big element, then it'll have small oxidation state.
Bigger has a smaller oxidation state and the smaller has a higher oxidation state, which is more stable. So if I talk about the smaller element like boron and aluminium, it will have a tendency to show +3, and the other elements का +1 oxidation state stability would increase. तो thallium जो है normally +1 में ही exist करेगा. अब इससे एक क्वेश्चन बन सकता है कि अगर थैलियम +3 ऑक्सीडेशन स्टेट में कोई कंपाउंड बनाता है, इज इट स्टेबल?
No.
So it will try to come to its stable oxidation state. That is what.
+1.
So in this process, it is actually undergoing what?
Reduction.
Reduction.
So thallium in the +3 would act as what?
Oxidizing agent.
Perfect. समझा? एक बहुत अच्छा क्वेश्चन कॉन्सेप्चुअल बन सकता है कि if we have a compound in which thallium is in the higher +3 oxidation state, it is not stable. So that is why it will try to come to its stable form of +1. In that process, it undergoes reduction and thallium +3 would behave as an oxidizing agent. Now, coming to the boron concept. Because of the small size and high polarizing power, sorry, what type of compounds will boron form? Covalent or ionic?
Covalent.
Covalent. तो बोरॉन अपने जो भी ट्राइवेलेंट कंपाउंड्स बनाता है, दैट इज PCl3 और द बोरेन BH3, दे आर ऑल कोवेलेंट कंपाउंड्स. और अगर वो कोवेलेंट है तो कैन इट एग्जिस्ट एज अ B+3 आयन?
No, sir.
ऑक्सीडेशन
No.
स्टेट +3 हो सकता है, लेकिन क्या वो अपने आयोनिक फॉर्m में B+3 एग्जिस्ट कर सकता है?
No.
नहीं.
Because the sum of the three ionization enthalpies IE1 plus IE2 plus IE3 is so very high that to exist in the +3 oxidation to exist in the +3 ionic form, it is very very difficult. So remember, boron does not exist in +3 ion, though its oxidation state is +3. ऑक्सीडेशन स्टेट +3 का मतलब वो अपने 3 इलेक्ट्रॉन बॉन्डिंग में पार्टिसिपेट करवा रहा है. It can be sharing also. It need not necessarily be loss of the 3 electrons. See, these are two very different things. Huh? Oxidation state of boron +3 means that 3 electrons are participated in bonding. And bonding कोई भी तरह का हो सकता है. It can be a coordinate covalent bonding, नॉर्मल कोवेलेंट हो सकता है या आयोनिक हो सकता है. So if we talk about boron, it does not form a B plus 3 ion, though its oxidation state is plus 3. And that's what is the first point, which is very important. Due to small size of boron, the sum of the first three ionization enthalpies is very high. This prevents it to form plus 3 ions and forces it to form only covalent compounds. And the covalent character down the group will decrease, rather the ionic character down the group will increase. And this is in accordance with a very famous rule which we always discuss, that is Pachan's rule, and a very important point to be noted. Then the relative stability of plus one oxidation state progressively increases for heavier elements, where thallium in the plus one would be the most stable. Point 3 very important जो मैंने डिस्कस किया. In thallium, the plus one oxidation state is predominant, whereas plus 3 state will be highly oxidizing in character. अब ये समझा. Plus 3 oxidation state in thallium would be oxidizing in character. And this you can apply for any of the group. Any of the group. जैसे नाइट्रोजन फैमिली में हमारे पास बिस्मथ है, तो बिस्मथ जो है वो प्लस 3 में ज्यादा स्टेबल होगा. तो अगर if it has a plus 5 oxidation state, then it will try to stabilize to plus 3. In that process will undergo oxidation, reduction, and will behave as the oxidizing agent. So it holds true for any of the other groups also. Then point 4, the compounds in plus 1 are more ionic than those in the plus 3 oxidation state. See in the notes there are lot of points which are given, but उनमें से सारे points हम already पहले discuss कर चुके हैं. तो जो points important है वो मैं यहाँ पर discuss कर रहा हूँ with their reasons. Fine. You have to go through all the points and mark the important points whichever you feel are uh, can be converted in the form of MCQs. Then BCl3, which is a covalent compound, accepts a lone pair of electrons from ammonia to form BCl3.NH3 complex. So now look at this reaction. BCl3 as a covalent compound adds up with ammonia, where nitrogen has an extra pair of electron. So because of that, ammonia here behaves as a Lewis. Ammonia behaves as a Lewis,
Base.
and BCl3 has electron deficient centers, so it will behave as a Lewis
Acid.
acid. So now the lone pair from the nitrogen would be donated to boron, and it will form a coordinate bond directed from nitrogen to boron. Now a question which could be asked: in this reaction, before the reaction happens, what is the hybridization of boron?
sp2.
sp2, and that's the reason it is planar. After the reaction, it has a tetravalence of, it has a covalence of 4, because of which now the hybridization is changed to sp3 and the geometry is tetrahedral. So a question could be framed over here: when BCl3 reacts with ammonia, the hybridization of boron changes from dash to dash, changes from sp2 to sp3, or the geometry changes from planar to tetrahedral. So the point which is given, we have converted that in the form of MCQ. This is how the questions are asked. Other way around, जैसे मैंने यहाँ पर बताया, in this reaction BCl3 acts as a Lewis acid, or organic chemistry point of view, this is an electrophile, and ammonia as a Lewis base act as a source of nucleophile. वैरायटी ऑफ क्वेश्चंस यहाँ पर बन सकते हैं, समझा?
Yes, sir.
अब एक इंपॉर्टेंट और एडिशनल पॉइंट जो नोट्स में नहीं दिया है, ये आप नोट कर सकते हो, ध्यान दो। BCl3 versus AlCl3. If I talk about the existence of the compound, BCl3 exists as a monomer, लेकिन AlCl3 it is found to exist as a
Dimer.
dimer. In fact, AlCl3 actually exist करता है Al2Cl6 के फॉर्म में। ठीक है, तो बोरॉन के जो ट्राई हैलाइड्स है वो अल्यूमिनियम की तरह डाइमर फॉर्म में एग्जिस्ट नहीं करते, दो देयर इज इलेक्ट्रॉन डेफिशिएंसी इन बोथ दीज एलिमेंट्स। सो व्हाट इज द रीजन फॉर द बोरॉन हैलाइड्स टू एग्जिस्ट एज अ मोनोमर? मैंने थियोरी में डिस्कस किया है इन डिटेल। कैन एनीवन justify this? Why BCl3 exists as a monomer? Yes, anyone?
It can stabilize itself
Perfect. It stabilizes itself. कैसे?
with the lone pair
Whose lone pair?
chlorine.
Perfect. And what type of bonding is that? Special नाम है. Whenever the bonded atom donates electron to the central atom, it's called back bonding. It's called back
Back bonding.
bonding. And this back bonding forms a double bond, meaning it forms a pi bond. And the orbitals involved over here are p orbital. So what was the name given to this bonding overall?
PP back bonding.
P pi back bonding. It's p pi back bonding. और सबसे ज्यादा efficient p pi back bonding किस में होगा? Between boron and which halogen? See, for back bonding, the orbitals should be of the similar size so that the overlap is effective. तो बोरॉन सेकेंड पीरियड में है, तो किसके साथ वो इफेक्टिव बैक बॉन्डिंग कर सकता है?
Fluorine.
ऑफ कोर्स, इसीलिए BF3 में जो पी पाई बैक बॉन्डिंग है वो सबसे ज्यादा इफेक्टिव और सबसे ज्यादा स्ट्रॉन्ग होगा। नाउ लिसन टू दिस, वेरी इंपॉर्टेंट। सो इफ वी हैव अ बोरॉन ट्राइहैलाइड, we know that it has sp2 hybridization and the geometry is planar. So if in this halide I consider the fluorine atom, then in BF3, this lone pair from the fluorine can be donated to the electron deficient boron atom. क्यों इलेक्ट्रॉन डेफिशिएंट है? बिकॉज उसमें सिर्फ 6 इलेक्ट्रॉन्स हैं एंड टू स्टेबलाइज इट रिक्वायर्स 2 इलेक्ट्रॉन्स। तो फ्लोरीन बोलता है आई एम योर बॉन्डेड एटम, आई हैव द एक्स्ट्रा इलेक्ट्रॉन पेयर, आई कैन डोनेट इट टू यू एंड यू कैन बिकम स्टेबल। बराबर? अब ये पॉसिबल इसलिए भी है क्योंकि बोरॉन में देयर इज अ वेकेंट p orbital, there is a vacant p orbital, and fluorine में there is a filled p orbital which has the electrons. So this filled electrons can be donated to the vacant p orbital, and when the bonded atom donates to the central atom, the type of the bond formed is back bonding, and ये pi bond बना रहा है इसीलिए pi back bonding है, p orbitals involve हो रहा है इसीलिए this is p pi p pi back bonding. p pi back bonding. समझा? So now BF3 has the strongest p pi back bonding, followed by BCl3, BBr3 and BI3. अब ध्यान देना, एक बहुत इंपॉर्टेंट क्वेश्चन की तरफ हम चल रहे हैं. All the boron trihalides exist as Lewis acids, and a strong Lewis acid is that which would have an easy tendency to accept electron pair. A strong Lewis acid would be that which have easy tendency to accept an electron pair. So tell me, which is the good Lewis acid out of the four given?
Pi3.
Bi3. बिकॉज क्या हो रहा है कि BF3 में फ्लोरीन बहुत ही ज्यादा बोरॉन को स्टेबलाइज कर रहा है ऑलरेडी, तो उसको बाहर से इलेक्ट्रॉन एक्सेप्ट करने की जरूरत नहीं है. बट व्हेन इट कम्स टू Bi3, बोरॉन का जो p ऑर्बिटल है वो तो छोटा ही है ना, लेकिन हैलोजन में एज वी मूव फ्रॉम फ्लोरीन टू आयोडीन, द ऑर्बिटल साइज ऑफ द फिल्ड ऑर्बिटल वुड इंक्रीज. अब छोटे ऑर्बिटल का बड़े ऑर्बिटल के साथ ओवरलैप इतना ज्यादा स्ट्रांग नहीं होता है, इसीलिए Bi3 में द पी पाई बैक बॉन्डिंग इज वीकर और लेस एफिशिएंट बिकॉज ऑफ लेसर ओवरलैप. इसीलिए नाउ द Bi3 will have the tendency to accept the electron from the external source also, and that is the reason Bi3 now would be a good Lewis acid and BF3 would be a weaker Lewis acid. So this is the Lewis acid strength. Acha, if I keep the halogen to be constant, then between the BX3 till thallium halide, trihalide, which is a good Lewis acid.
Boron.
But of course, बिकॉज बोरॉन में स्मॉलर साइज की वजह से इलेक्ट्रॉन एक्सेप्ट करने की टेंडेंसी ज्यादा होगी, प्लस उसका जो +3 ऑक्सीडेशन स्टेट है वो ज्यादा फेवरेबल है. इसीलिए स्मॉल साइज की वजह से डाउन द ग्रुप द ल्यूइस एसिड स्ट्रेंथ विल डिक्रीज. These are two very very important questions which could be asked in regards to the Lewis acid strength. Keeping boron fixed and halogen variable, BF3 is the weakest Lewis acid. Keeping halogen fixed and varying the p block group 13 element, boron का trihalide is strongest Lewis acid. Fine.
Yes, sir.
अब मैंने इसके अलावा और भी कुछ कॉन्सेप्ट्स बताए थे. जब ये इफेक्टिव ओवरलैप होता है, तो दिस पर्टिकुलर बॉन्ड बिटवीन B and F actually exists as a double bond, and there can be multiple structures possible, in fact 3 structures possible, where this pi bond could be existing between this B and F or this B and F also. So overall ये जो pi electron है ये अपनी जगह पे fixed है ही नहीं, it is distributed between the 3 BF bonds, and that is why BF3 exists as a resonance hybrid in which one pi bond is distributed between the 3 BF positions. And that's why if the bond order is asked of the BF bond, the answer will be bond order
1 plus 1/3.
1 प्लस एक पाई जो 3 में बटा, एक सिग्मा है और एक पाई जो 3 में बटा, इसलिए 1 प्लस 1/3, 4/3 या 1.33 is the bond order of BF3. सो 4 क्वेश्चंस यहाँ पर बन सकते हैं. पहला, BCl3 और अ बोरॉन ट्राइहाइड एग्जिस्ट एज अ मोनोमर, बट उसी ग्रुप का अल्यूमिनियम क्लोराइड डाइमर के फॉर्म में एग्जिस्ट करता है. Lewis acid strength के ये दो ऑर्डर एंड द बॉन्ड ऑर्डर ऑफ BF in the BF3 एंड ऑल्सो जो कॉन्सेप्ट यहाँ पर रिलेटेड है दैट्स नेम्ड एज पी पाई बैक बॉन्डिंग. ये सब एडिशनल पॉइंट्स है which are asked in the MCQs, so you should be noting down this. Now ये भी पूछा जा सकता है या ये क्वेश्चन आपके दिमाग में भी आ सकता है कि जब BCl3 मोनोमर के फॉर्म में एग्जिस्ट करता है तो AlCl3 भी करना चाहिए. वैलिड है, लेकिन प्रॉब्लम क्या होता है कि एल्यूमिनियम में जब हम ट्राइहाइड्राइड को देखते हैं तो यहाँ पर जो p ऑर्बिटल है वो 3p का होगा. Now that will be bigger in size. So because of this higher size of the p orbital, larger size of the p orbital, the overlap or the p pi back bonding is not that efficient. इसीलिए AlCl3 internally या within the molecule stabilize नहीं हो सकता because of the larger size of the p orbital. So we say the BCl3 or boron has p pi back bonding which is effective, but aluminum can't have the effective back bonding possible because of the larger size of the p orbital. Fine. Next, AlCl3 achieves stability not by existing as a monomer but by forming a dimer. And there is this chloro-bridged dimer which is formed for the Al2Cl6, wherein now the aluminium का hybridization is sp3. अपने डायग्राम में भी एक्स्ट्रा पॉइंट्स लिखते जाओ. Aluminium का hybridization is sp3 and the geometry is tetrahedral. And when I talk about this chlorine giving electron pair to the aluminium, it is actually forming a coordinate covalent bond. एंड जब कोऑर्डिनेट कोवेलेंट बॉन्ड होता है तो इस डाइमर में जो ब्रिज वाला बॉन्ड है वो अपना नॉर्मल बॉन्ड है, ना कि बनाना बॉन्ड. ध्यान है ना ये. बेरिलियम का हाइड्राइड वर्सेस बेरिलियम का क्लोराइड, व्हेन इट एग्जिस्ट एज अ पॉलीमर, what was the difference in the bonding? Quickly tell me.
Hydride is banana bond.
The hydride ka bridge bond is a banana bond, but in BeCl2 the chloro ka bridge bond is not a banana bond because the case is similar to this only. तो इस केस में भी जो क्लोरो है वो अपना लोन पेयर डोनेट कर रहा है, जैसे बेरिलियम में क्लोरीन वाज डोनेटिंग अ लोन पेयर टू द बेरिलियम एटम. सो थिंग्स जो सिमिलर है वो यहाँ पर ध्यान रखना है. इन दिस देयर इज 3 सेंटर्ड 2 इलेक्ट्रॉन बॉन्ड बिकॉज हाइड्रोजन लोन पेयर नहीं दे सकता, बट इसमें 2 सेंटर्ड 2 इलेक्ट्रॉन बॉन्ड होता है. क्लियर. तो हाइब्रिडाइजेशन और ज्योमेट्री पे बहुत सारे क्वेश्चंस बन सकते हैं. मोनोमर है, डाइमर है कि पॉलीमर है, उस पे क्वेश्चंस बन सकते हैं. ठीक है. नेक्स्ट, BCl3 on hydrolysis in water form a tetrahedral MOH4 negative species. The hybridization state of element M is sp3. तो बोरॉन के हैलाइड्स जब हाइड्रोलाइज होते हैं तो it forms BOH4 negative species and hybridization because of tetravalence is sp3. लेकिन aluminium chloride in the acidified aqueous solution forms the octahedral complex ion because in that case the covalence can be expanded beyond 4. तो अब आता है बात max covalence का. And the trick or the general rule is second period has a max covalence of only
4.
4, but the other elements can expand the covalence beyond 4 because of the presence of vacant d orbitals. तो ये भी डायरेक्ट क्वेश्चन आ सकता है. अल्यूमिनियम का क्लोराइड यानी AlCl3 एसिडिफाइड एक्वियस सॉल्यूशन में कौन सा आयन बनाता है और उसका हाइब्रिडाइजेशन क्या है, और वो अपना कोवेलेंस 6 तक एक्सपांड क्यों कर सकता है. तो अगेन, variety of questions can be found from this. So the ion formed is AlH2O6 3 plus. The geometry here is octahedral, and with 6 bonds the hybridization would be obviously sp3d2, and the covalence over here is 6 because of the involvement of 3d orbitals of aluminium. The covalence is 6. Here the covalence for the species is 4, which is also the max for the second period element. Fine. So now coming to the next part, that is chemical reactions. First part में reactivity towards air. As we discussed that boron has two allotropic forms, crystalline and amorphous. So boron is unreactive in the crystalline form, but अगर मैं amorphous boron की बात करूं, amorphous boron, then it can burn in oxygen to form B2O3, or it can react with the nitrogen of air to form a boron nitride, that is +3 -3. और ये जो boron nitride है, it has a structure similar to graphite. That is why the Bn compound is called inorganic graphite. Sorry, the Bn is named as inorganic graphite. Sorry, वही था, inorganic graphite, because of the structure similar to the graphite. ठीक है, तो एड ऑन कर लो ये .1 के सामने ही. एमॉर्फस बोरॉन ऑक्सीडाइज होकर ऑक्साइड बनाएगा और नाइट्रोजन के साथ नाइट्राइड बनाएगा. जो Bn बनता है वो इनऑर्गेनिक ग्रेफाइट कहलाता है बिकॉज ऑफ द रिजेम्बलेंस टू ग्रेफाइट. Point B, aluminium forms a very thin oxide layer on the surface which protects the metal from further attack. This is how aluminium is prevented from corrosion on its own. Then amorphous boron and aluminium metal on heating in air forms B2O3 and Al2O3 respectively. With dinitrogen at high temperature, they form a nitride. Now, the nature of these oxides varies down the group. Boron का trioxide acidic है because non-metal oxide है and reacts with the basic or metallic oxides forming the metal borates. Whereas aluminium and gallium oxides are M4, indium and thallium are basic in nature. तो बोरॉन का ट्राइऑक्साइड B2O3 एसिडिक है, अलुमिना एंड Ga2O3 गैलियम ऑक्साइड एम्फोटेरिक है, इंडियम एंड थैलियम बेसिक है. तो ये नेचर भी पूछा जाता है, ऑक्साइड्स नेचर. And as a general rule, the above oxides are non-metallic and acidic. The below oxides are metallic and basic. Then towards acids and alkalis. Acids and alkalis के साथ वही react करेगा which have the amphoteric nature, meaning gallium and aluminium have this property. बाकी के लिए obviously it will not react with both of them. So boron does not react with the acids and alkalis even at moderate temperature because of a high crystalline nature of boron. But aluminium dissolves in the acid and aqueous alkalis and thus shows amphoteric character. So acid के साथ aluminium forms the salt and liberates a dihydrogen gas. So again a question which could be formed. When aluminium reacts with the acid, it liberates a gas named dihydrogen. H2 gas release करता है. ना एक और पॉइंट, जब ये aqueous solution होगा ना, तो this aluminium ion would exist as a hydrated ion AlH2O6 3+, जिसमें इसका हाइब्रिडाइजेशन sp3d2 हो जाता है एंड ज्योमेट्री ऑक्टाहेड्रल हो जाता है. जस्ट बिफोर दिस आई डिस्कस दिस. तो एक्वियस सोल्यूशन है, अल्यूमिनियम हाइड्रेटेड फॉर्म में एग्जिस्ट करेगा. तो ये पूछा जा सकता है When aluminium is dissolved in acidified aqueous solution, the cation is surrounded by dash water molecules or the coordination number, meaning the number of waters which is associated with aluminium is how much. So सबका मतलब एक ही है. The coordination number is 6, meaning 6 water molecules are bonded. Then, however, concentrated nitric acid renders aluminium passive by forming a protective oxide layer on the surface. So, this process in which the metals are dissolved in the nitric acid to form an oxide layer on the surface is basically named as passivation. तो इसमें होता क्या है, जो मेटल्स है उनको हम पैसिव बना देते हैं by forming an oxide layer by the reaction with nitric acid. And then aluminium also reacts with the alkali and liberates dihydrogen. तो यहाँ पर भी जो गैस लिबरेट हो रहा है वो डाइहाइड्रोजन ही है, which is common for both the reaction. But the product which is formed in the acid case is AlCl3 with hydrated aluminium ion, and the product formed in the basic alkaline medium case is AlOH4 negative. So the complex here is named as sodium tetrahydroxoaluminate with the oxidation state of aluminium S plus 3, written as the stock notation, that is in the Roman numeral. Sodium tetrahydroxoaluminate. Is the difference clear? Yes? Hello?
Yes, sir.
Yes.
Then the reactivity towards halogens. तो यहाँ पर दो पॉइंट्स जो नोट करके मेंशन किए हैं, दे आर इंपॉर्टेंट, उसके ऊपर क्वेश्चंस आए हैं. Anhydrous aluminum chloride, which is a famous Friedel-Crafts catalyst. The moment you see anhydrous AlCl3, याद रखना, it is an important compound for the Friedel-Crafts reaction. So anhydrous aluminum trichloride is prepared by heating alumina in carbon and dry chlorine gas. Direct यही statement आया हुआ है, and this was not given in NCERT. I have added it as a note. So AlCl3 कैसे बनता है? By heating alumina with carbon. So what happens over here? The carbon takes away the oxygen to form the monoxide, and now the aluminium and chlorine reacts to form AlCl3. So what is the role of carbon over here?
Reducing agent.
Carbon is a reducing agent. अच्छा, और एक चीज अगर याद है तो बेरिलियम का क्लोराइड भी ऐसे ही बनाया था. We had heated beryllium oxide to a temperature of 600 to 700 Kelvin in a current of chlorine, wherein carbon takes away the oxygen to form carbon monoxide and beryllium chlorine combine होकर BeCl2 बना देता है. Exactly similar reaction है बेरिलियम का भी, और इससे बेरिलियम और एल्यूमिनियम का डायगोनल रिलेशन भी रिलेट हो जाता है. सिमिलर प्रॉपर्टीज. Then it is partially hydrolyzed with atmospheric moisture to liberate HCl gas, and moist HCl appears white in color, hence white fumes appear around the bottle of anhydrous aluminum chloride. तो जो anhydrous aluminum chloride जो भी बॉटल में प्लेस करते हैं उसमें से व्हाइट फ्यूम्स अपीयर होते हैं. तो ये पूछा जाता है कि वो व्हाइट फ्यूम्स किसकी वजह से होता है? इट इज ड्यू टू द हाइड्रोजन क्लोराइड और हाइड्रोक्लोरिक एसिड इन द गैसियस फॉर्म, क्योंकि वो पार्शियली हाइड्रोलाइज हो जाता है, एंड इन दैट प्रोसेस इट हैज अ टेंडेंसी टू लिबरेट द HCl गैस. क्लियर? Now coming to the some important compounds of boron. The first and the most important compound is borax, and it is a white crystalline solid having a formula Na2B4O7.10H2O. It exists as a decahydrate with 10 molecules of water of crystallization. In fact, it contains the tetranuclear units of B4O5OH4 2 negative, and the correct representation of borax is this, where the formula to be written is Na2B4O5OH4 dot 8H2O. तो ये सारे के सारे 10H2O मॉलिक्यूल्स वाटर ऑफ क्रिस्टलाइजेशन के फॉर्म में एग्जिस्ट नहीं करते हैं. The four hydroxyl groups are present within the complex ion, and the complex which is formed is Na2B4O5OH4. तो ये करेक्ट रिप्रेजेंटेशन बोरेक्स का पूछा जाता है, ये आपको ध्यान रखना है. Na2B4O5OH4 and dot 8H2O. Then borax dissolves in water to give an alkaline solution. So borax is a salt, और सॉल्ट को पानी में डालोगे तो it will hydrolyze करके the cation will form the NaOH, and the boron will form the acid which is H3BO3. The combination of this is a strong base with a weak acid, तो solution बन जाएगा alkaline, and alkaline solution का pH जो है वो greater than 7 होता है. Then on heating, borax first loses water molecules and swells up. On further heating, it turns into a transparent liquid. It solidifies into a glass-like material known as borax bead, and this is used in the testing of the transition metal with a special name called as borax bead test. तो इसके रिएक्शन में क्या होता है? Na2B4O7.10H2O, the borax compound. When it is heated, it can lose away the water molecules and form sorry, Na2B4O7. Further अगर हीट करे तो it forms NaBO2 and B2O3. So this NaBO2 compound is named as sodium metaborate. Sodium metaborate. And this B2O3 is simply the boron का oxide, but एक special name है इसका boric anhydride. B2O3 is named as boric anhydride. And this NaBO2 can be used in the testing of the transition metal. अब क्या होता है, जो मेटाबोरेट्स बनते हैं उसमें एक स्पेसिफिक कलर होता है, उस कलर के थ्रू ट्रांजिशन मेटल कुड बी आइडेंटिफाइड. जैसे कोबाल्ट ऑक्साइड व्हेन हीटेड विद द NaBO2, the sodium metaborate, it forms cobalt metaborate. अब कोबाल्ट मेटाबोरेट का फॉर्मूला कैसे लिखना है? Cobalt is in the +2 state and the borate is in the BO2 -1. So this formula would become COBO2 twice, and because of the blue color we can confirm the presence of the transition metal cobalt. वैसे ही क्रोमियम का ऑक्साइड Cr2O3 can also be tested with the borax bead, and here the color which is formed is green. तो ये पूछा जाता है कि the green color of the chromium bead is due to the formation of which compound? What would be the answer? Green color किसकी वजह से बना? What would be the name and the formula of the compound? The blue color is due to cobalt metaborate, so the green color in the chromium test would be due to dash.
Chromium metaborate.
Can you tell me the formula?
CrBO2 twice.
Twice Q.
Thrice. Thrice.
Chromium is +3 over here. So +3 and a -1. So
Thrice.
CrBO2 twice. फाइन, ये क्वेश्चन आया हुआ है, तो क्रोमियम का भी कलर पूछा जाता है. इट्स in the +3 oxidation state green colored, and the compound formed of metaborate is chromium metaborate CrBO2 thrice. So let's see the statement. The metaborates of many transition metals have characteristic colors, and therefore borax bead test can be used to identify them in the laboratory. Example, when borax is heated in a Bunsen burner flame, और ये flame again oxidizing flame होता है, which is the hottest part of the flame because it is burnt in the unlimited supply of oxygen. So with cobalt oxide on a loop of platinum wire, a blue colored cobalt metaborate bead is formed. तो कलर और उसका फॉर्मूला इस बोरेक बीज टेस्ट में इंपॉर्टेंट है, जो पूछा जाता है. एक ब्लू कलर तो याद रखो कोबाल्ट का होता है, और ग्रीन कलर क्रोमियम +3 का होता है. ये दो कॉमन क्वेश्चंस आए हुए हैं इस टॉपिक से. ठीक है. Okay, so I'll not start with the next topic because it will take time to complete. I'll stop here for today. What we have completed in today's session is the initial periodic properties, physical properties, chemical properties, and then we started with the compounds of boron, जिसमें borax को discuss किया है. And whatever possible questions could be asked from the topic, I have discussed them with all the additional points also included. Make sure you note down all the additional points. Along with that, type of questions जो आ सकते हैं उसका thought process develop करो. So inorganic में that would be the best way. And one more point, make your own notes. That would help you to a great extent.